think we're streaming. We'll see whether YouTube agrees. There we go. It started. Hey, everybody. Smitty Halibut here. It's been a while since I've done one of these streams. Of course, every stream I starts out that way, doesn't it? But today we're going to be working on a speaker level mixer. So I've got a lot of devices like HTs, like mobile rigs, like computers and things like that. Well, not computer, but that output audio at the level of a speaker, which is often a higher voltage, almost certainly a lower impedance than line level. And so you can't easily just plug the speaker level output into a line level mixer without screwing things up. You also can't do because the speaker levels are often push-pull, so you can't just run that into a ground referenced signal. So you need to do some isolation and some padding and some mixing and some other things. So that's what I'm building. I have a playlist already of the first couple versions of this mixer that I made, and there were problems with them, and we're going to go over what those problems were and how I intend to fix them. The ideal use case for this is I want to have it in the back of my car, mixing the speaker output from my D700 as one radio, my FT100 as a second radio, possibly, it's not speaker level, but adding in a line level mix from Raspberry Pi that's back there. And then fourth is possibly my HT, my Anytone DMR HT that I just bought. Which will that audio will have to come from the front going to the back. The idea is to mix all of these together, re-amplify them into speaker level, and then send them to one speaker at the front of the car on the dashboard, so that I have just one speaker with all of the audio sources going into it. I don't have to have 4 different speakers up there. And in that way I can optimize it for one good speaker, good quality speaker, and I don't have a whole bunch of clutter all over my dashboard. So that's the goal. That's what we're going to be working on today. So yeah, let's get into it. First and foremost, when it comes time for me to stop blabby and start working, I'm going to be listening to a little bit of music. This album, Battletech, the original soundtrack. So Battletech is a game being put out by Harebrained Schemes. They're the folks who did the Shadowrun games that I like so much. And John Everest is the musician, the composer who did the music for the Shadowrun games, and he is also doing the music for their new game called Battletech. The game comes out on the 24th, which is in 3 days from when I'm doing this live stream. And you can pre-order the digital album of the soundtrack. And I am so looking forward to this. I have pre-ordered it, and we get 6 tracks now, and then we'll get the whole album when it comes out. All of his music is fantastic. So Battletech, Shadowrun Hong Kong. I haven't actually listened to Necropolis yet. I didn't even know that was a thing. I need to go buy that one. But Shadowrun Dragonfall is the other one of his that I know. And it looks like he's got a few albums in here that I don't own yet, so I need to go fix that. But we're going to be listening to this. The volume's going to be low, so I can still kind of talk over it. If you're interested in the music and you like it, go buy this album. It is fantastic, at least the 6 songs that I've heard so far. His 2 Shadowrun soundtracks were also phenomenal, Hong Kong and Dragonfall. They are among a couple of other albums that game soundtracks that I listen to, among my favorite get stuff done music. I'll put them on in the background while I'm at work with my headphones, and I can just ignore the rest of the world and concentrate and get stuff done, and it's beautiful music. So anyway, highly recommend it. We're going to be listening to that. This link will be in the show notes here, johneverest.bandcamp.com, to go buy his albums if you're interested. You can stream them from there. You can get FLAC downloads and all that fun stuff. So I'm going to hold off on that until I am done talking. So here's the speaker mixer project that I'm working on. This is KiCad, like I'm used to doing. Let's see here. So this was the first version of the board that I ordered. And let's take a look at this. So it's a pretty simple mixer. These are the inputs, the speaker inputs, and I have a 100 ohm resistor across the speaker input. The idea there is that amplifiers like to have a load, and normally this is like an 8 ohm load, but I don't need to draw full power out of it. I just want to have enough of a load that it will draw some power, enough for the amplifier to be working. So a higher impedance there than it's used to seeing is fine. I think I dropped this to 47 in my the breadboard version that I've been working on. And then this original version, I tried using capacitors to do the DC blocking. And that works fine as long as it's single-ended. Fine, I'll use the term loosely. As long as your speaker output here is single-ended, where one side is ground, and then you do a capacitor to ground, and that's fine. And then the other side has signal, and you got a capacitor going into your mixer bus. Not all of my sources are that way, so I needed to do something differently than just capacitors. If you try to send a signal in through this line here, through that capacitor, it does bad things. But here's the trim pot. That is just kind of a... that's the mixer where you actually adjust the relative levels of each of your inputs. Then this is a standard negative feedback inverting amplifier that also does mixing. I'm not going to go into the details of how a mixer works here. I think I've talked about that in the past, but short answer is here's the simple mixer setup. A DC blocking cap and then the output. And this is a line level output. The TL072 can't source a lot of current, so this is great for sending into another amplifier, but not running into a speaker. We got a little bit of power conditioning, just kind of a bulk capacitor here, 100 microfarads, and then you know, various different values of caps just to provide some lower impedance at all the different frequencies. This is a artificial ground generation circuit. So I don't have positive and negative rails. I don't have a positive and a negative voltage that I can use for the op amp. So we have to do 12 volts and ground, and then the audio has to be between that 12 volts and ground. So I got a 12 volts up here and a ground down here. The audio needs to stay. The audio needs to stay between the 12 volts and ground potential, and so you have to take your audio, which normally comes in down here around ground, and then kind of shift it up so that it's halfway between your positive and your negative voltage rail, and that's what this does. So I got a 12 volts and a ground, and let me move these. Nope. Yeah. Okay. I'll move that back later. So I got a 10K and a 10K. The idea being that this is a voltage divider that's just going to take that this point right here is going to be half of the voltage between 12 volts and ground. So this will be about 6 volts. And and then you have a capacitor here just to kind of filter out any noise. So this should be a very clean, solid halfway point. 10K and 10K, so it's relatively high impedance. I couldn't actually drive any of the audio circuits here because the lower impedances over here would overrule those, and your virtual ground would start moving all over the place. But instead, we feed that into an op amp. And so I say, here's my voltage, 6 volts. Feed that into the positive. The negative is just tied back in, and this is called a voltage follower op amp. This output voltage will be exactly the same as the input voltage on the positive side of the op amp, but that op amp is able to source a whole lot more current. So it's a much, much, much lower impedance than this 10K impedance here. And so this is my virtual ground. I'm calling this my ground. You'll note that, so this is GND-A as an analog ground as opposed to this, which is the power ground. So all of these things are done relative to analog ground. I've got an analog ground here, analog ground on this mixer here. Everything between those capacitors which are blocking DC and that capacitor which is blocking DC, everything in between there, the quote-unquote ground is the analog ground, which is actually the output of this. So I want to use this mixer section here. Let me undo that change. I want to undo this mixer section here, actually, including up to this part, up to these resistors. I want to use this from this version of the board, but these DC blocking caps here did not work. Furthermore, having the trim pot after the isolation section didn't work either. That was the big problem that I ran into. So let's look at the version 1.1. I'm going to do that. Nope. Exit without saving. Let's look at version 1.1. Schematic. Nope, that was already there. Okay. So what did I do differently? Oh, really? That's unfortunate. All right, there was a big chip here called an SSM2166. Apparently, I don't have the right library loaded. It is a big audio processing chip. This was way too complex. I tried to use it as an audio gate, i.e., when the volume is low, it'll pull it down to ground and make the audio go to 0. So, like if you got just a background hiss, kind of a that would be below a certain threshold, and anything below that threshold would just shut down. It would just block it. It would close the gate. It would turn off the audio. But then as soon as the input audio got above that threshold, then it would open that gate and the audio would go through. That was the idea. It's called an audio gate. And I never really got it working, and it's a lot of components, and it's complex, and I'm just like, nah, forget it. I want to go back to the simple mixer. So I'm going to use the mixer side of version 1.0. However, over here you will notice that we have audio transformers. This is the right way to do the audio isolation from the speaker side to the mixer side. The thing that I screwed up on here is by having the trim pot on the line level side of the audio isolation transformer. If these transformers were bigger and beefier and could handle more power, then that would be fine. But they can't. They're small. They are meant for line level. They are not meant to have speaker level going through them. And so when I have the speaker level power ratings going through this coil on the side, the primary coil here, these transformers went into saturation, and it sounded like crap. It was horrible. It sounded horrible. It did not work. So what I need to do, and that's what I tested here. Let me go back to the other video feed. So this is my version 1.0 board here, this purple one, that's got the simple mixer on it, but it had all the pots and caps of the isolation side, which didn't work out so well. So what I did is I breadboarded the new isolation side and then just ran the wires into this board. And then here's my little external amplifier that I'm using to re-amplify this signal and send it out to the one speaker on the dashboard. So you'll note that the inputs come in, and this is just a 1/8 inch TS signal from a speaker output. Input comes in. First thing it does is it gets trim potted. So I am bringing that speaker level voltage down to something that's more appropriate for a line level. Then I feed it through the isolation transformer. And then from the output of the isolation transformer, I feed it into the mixer. That was the big mistake that I made on both of these, is that I tried to isolate it first and then trim pot it down. The right thing to do is to pot it down and then isolate it. So we're going to use kind of a modified version of this front end. Then we're going to use pretty much a straight copy of the version 1.0 mixer side and put that all together onto a board today. So that's what we are going for today. Oopie, I was just pointing at things that you couldn't see. We are going to use, sorry, do that again. The input side here, but modified, where the trim pot and the isolation transformer are reversed from each other. Yeah, man, why do you not have the pot in there either? I must have been working on this on a different computer. But then we're going to use the mixer section from the version 1.0. So we're going to kind of combine the 1.0 and the 1.1 together into a single board, and then we're going to modify a few things. So let's get started. I'm going to go ahead and start up the music now. Again, this is the BattleTech soundtrack from John Everest. It's available for pre-order now. The link is down below. The Bandcamp link, johneverest.bandcamp.com. I haven't seen anybody in chat yet, although I do have a few people watching. I'm going to be looking for you guys who are watching, you folks who are watching the stream, to tell me what the audio mix is like, because I don't actually hear the mix from OBS. I hear the kind of the pre-OBS mix, and so I can't tell whether the background music is an appropriate volume or not. So let's get started. Let's take a look at this. What is our current? Okay, so that is, wow. You didn't have, okay. Anyway, these are the components. The components that were question marks in the previous version are shown up here. So let's get started on this. I'm going to change the input levels first, or the input sections first. Ah, come on. It's been a while. Come on. My mic sounds low. Hey, Vincent. Okay, check 1, 2. Let's see if we can turn the mic volume up a little bit. Does that help? Is that better? Check 1, 2. Check 1, 2. Mic volume levels are hopefully better now. Oh, better. Thank you. Actually, no, I don't want that there. I'm just going to redraw all this. Oh, nope. I don't like that. I'm just going to redo these blocks entirely. Okay. Okay. So we have 4 identical input sections. We got the 47 ohm load for the to give the speaker something to, or the amplifier to something to drive. Then we go into, actually those are, I'm doing 1Ks on those because that's a 600 ohm transformer. So I'd rather match those a little bit better. Okay, so those are the trim pots, which will bring the voltage level in from the speaker amplifier down to a reasonable level to send through the transformer. And then from the transformer, here's our analog ground again. This is just a chassis shield. It's not actually electrically connected to either side of this. But there's our analog ground on the secondary side. And then the 10K here matches the 10K, well, not that one, but it'll be the 10K on the mixer side to do, to set the gain on the mixer section. And we got 4 of those identical input sections. Okay. So we don't need a 5-volt reference because we're not going to be using that chip anymore. I don't think I want any of that. We don't need any of that either. Don't need those. Don't need any of these either. That I do want to save. Although maybe not that part. And then all of this I'm just going to delete because we will be dealing with that. Vince asks, what software am I using? If you're talking about the layout software, this is called KiCad, K-I-C-A-D, about KiCad. It's a, there's a term for it, I don't remember. Schematic and board layout program. There's like EDS, I think, electronic design software. I don't know. KiCad comes with Ubuntu, but it's it's available for Linux, Windows, and Mac. It's open source. Free as in beer and free as in speech. And one of my favorite things about KiCad is that you can upload the PCB file directly to Osh Park, and they do all the CAM work for you so that you don't have to delete junction. There we go. So you don't have to do all of the Gerber file outputs and figuring all that stuff out. You just upload the board file directly to Osh Park, and they'll take care of the rest for you. It's pretty cool. All right. So rather than try and copy things from a different version, I'm just going to go ahead and relay it out. TL072. So I'm not literally using an 072 here. I'll probably use a better quality. Well, maybe I will use an 072. Doesn't much matter because the op-amp pinouts are all pretty standard for dual op-amps. So you can literally drop any flavor of op-amp in here that you want. Yeah, I can't sing, I know. All right, so there's my power. Let's get a power connector on here. That one. And wait, what? No. There we go. Flip it. And then we're going to throw some filtering on here because filter all the things, bypass all the things. That is a 1 microfarad, so that's probably a 1206 surface mount. I will want to put an electrolytic on here as well. So I don't think we have any electrolytics on the board yet. So C, nope, P small. Okay. So that's going to be the decoupling cap around the op amp. That'll be our bulk power cleanup. And then if we need more, we can do more later. Whoa, what? Nope, 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 nope. Power. Okay. Okay. So ground analog, copy that one, put that there. So reminder of how inverting op amps work. You have to view it as a current source, or view it as a current device, and it makes the analysis of it a heck of a lot easier. So I've got sources over here. You know, there are voltage sources here, and then the output of the transformer is a voltage source. But between ground and then we put that voltage source through this resistor here, that's going to define a certain amount of current. So it's going to be trying to push a certain amount of current into this node. Because these two inputs, the op-amp will always try and keep these two inputs as close together as possible, and we have one of them tied to ground. Granted, it's our analog ground, but it's a ground. It's a constant voltage. So whatever current, so that means that the voltage of this node here is our ground, and it's going to be a fixed ground. So the voltage comes through here across a resistor to ground. That's going to define a certain amount of current. And that one's going to define a certain amount of current. This one's going to define a certain amount of current, depending on what those voltages are. And same with the other two, right? So I just pointed at my screen. You like that? So all of these are going to define a certain amount of current into ground. But the reality is that all of those currents get summed together because of Kirchhoff's current law. And then, let's see here, let me finish drawing the circuit so that this will make more sense. Because the input to an op-amp is very high impedance, it won't actually pass much current, very small amount, basically negligible amount of current here. So all the current that comes in through this node has to go out through this node. And so if I've got, let's say, 10 volts here, this is an extreme example for a line level mixer, but let's say I got 10 volts here across a 10K, that's going to push, carry the 1 milliamp. That's why I chose 10 volts, because it would make it a 1 milliamp. So if I've got 10 volts here, that's doing 1 milliamp, and then 0 volts on all of those, so they're not pushing any current at all. Then I've got 1 milliamp coming in here, and it goes through this node, and the only place for it to go is to go through here, so there's going to be 1 milliamp going through that 10K resistor. So this voltage here, the op-amp, has to drive that to a negative 10 volts for that to be the case. If this is 0, and there's 1 milliamp going down here, this has to be at negative 10 volts. And so the op-amp, through the magic of op-amps, drives this to a negative 10 volts for that to be the case. If it weren't at negative 10 volts, then the voltage on this node would not be our ground level. The voltage on this node would be something else, and that would create a voltage differential between the two inputs, and the op-amp would adjust the output to try and make those two inputs exactly the same. So if I've got a 10 volt here and zeros on all the others, then it's just 1 milliamp going through. But if I've got a 10 volt here and let's say a minus 5 volt here, right? So I got 1 milliamp coming in here, and I've got half a milliamp going the other direction. I'm drawing power out of the circuit. So by the time it gets here, it's only half a milliamp going toward the op-amp. And then so half a milliamp here, so that this means it's only minus 5. So I may be rambling here, but that's how we're mixing all of these inputs here into a single common signal. And then the output of this is an inverted version of the sum of all of those signals. I don't care about the inversion. Whether a signal is inverted or not is irrelevant for audio in this context anyway. So I don't care about the inversion, but I do care about the fact that this is a virtual ground, which makes all of these mix very easily. If I wanted to make some gain here, I could keep all of these 10K and make this a 30K. And that would mean that this would have to output 3 times the voltage of these inputs to be able to get the same amount of current to flow across that resistor. So I can get some gain out of this stage if I want to as well. I don't know if I want to. That's something I can adjust later, because all I have to do is swap out a 10K resistor for maybe a 30K or a 22 or a 47 or whatever, right? I can adjust the amount of gain that this amplifier will provide by adjusting the value of that single resistor there. So that's something I can figure out later. If I need more gain out of the system, or less gain possibly, then I can adjust the value of that resistor accordingly. Now, one thing that you don't have to worry about in perfect components, but we do have to worry about in the real world, is RF oscillations. So if I've got some gain here, and then there's any sort of a feedback loop, and kind of an oscillation feedback or a delay through this op amp, it will start oscillating at possibly high frequencies, and that does very bad things. So what we do is we put a bypass cap across this resistor, a very, very, very small value cap, so that the audio cannot pass through this cap. The audio still has to go through the resistor, which is where it gets its gain, but all of the high frequencies above audio, all the RF basically, does not go through the resistor. Instead, it goes through the capacitor, and the capacitor ends up being very low impedance for it, which means it has negative gain. So any oscillation that tries to go through there will be dampened. So this will, by having this capacitor here, it will allow audio to go through the resistor and still get gain, still get amplified, but anything above the cutoff, which is defined by those two values, will go through the capacitor and not get any gain. And the value of that, let's do the math. It's 1 over 2 pi r squared. So I'm a nerd, so I always use KiCad or BC. Zoom in, Control plus. Okay, so let's make this big so people can see it. All right. 1 over 2 times 3.14 times R, which is 10,000, times, let's try 100 puffs. So that's 1 microfarad, millifarad, nanofarad, 0.1 nanofarads, which is 100 picofarads. Okay. So this will give us the frequency of the transition frequency, the cutoff frequency for a 10K and a 100 picofarad capacitor in parallel. And that transitions at 160 kilohertz. And that's why I was thinking 100 picofarads, because that's what I use when I'm building audiophile amplifiers. I try to go at least 3 octaves out, so 20K to 40, 40 to 80, 80 to 160. So that is where I usually do my cutoffs when I'm doing audiophile amplifiers. This is not an audiophile amplifier, so I can actually use a bigger value there, like a 1 nanofarad or 1,000 picofarads, and that'll bring us down to 16K, which for this purpose is plenty. So anywhere between 100 picofarads and 1,000 picofarads, or a 0.1 nano and a 1 nano. Anywhere between there will get us in this range, and that's good for what we need to do. So I'm going to go ahead and call that, I don't know, what would a 2.2, 220 picofarad do? Nope. Let's do that. There we go. 72K. No, 1 nano, 1.5 nano. How's that? There we go. 10K. Nope, I'm going the wrong way. I want like a 470 picofarad. There we go. That's a good one. Let's go with 470 picofarads. Maybe even less or more than that. So like a 680 picofarads. Someone keeps trying to text me. Oh. Hold on for 1 second. We got guests coming over a little bit later. All right, let's go with 680 picofarads. That sounds good. And that is how engineering works. 680 puffs. You just kind of mess around with numbers until you get something that does about what you want. So now the combination of that 680 puffs and that 10K is going to cause anything above, what did we say? About 23 and a half kilohertz to be attenuated, so it will not feedback. So that's a good thing. All right, and then I already have that section, And let's just bring that over. Boink. Excuse me. I think that's all I want for the audio stuff. Keep that nice and simple. I still need to generate my analog ground, however. So let's do that. Unit B. So we have a second one in there. And how did we do that? We just had a couple of 10Ks in a voltage divide. Excuse me. Then I want, oh, this is voltage follower. So it's just direct feedback like that. Now, this is power, so that's a real ground. That's a 12 volt. Put that there. We may or may not need to actually redefine that because that pin 8 is the same as that pin 8 there. I'm not sure why they put that on both components. That doesn't seem like it's necessary. That's also a real ground. And then ground analog. Okay. So we got our power. Oh, I need a filter on that. I think I want one of... these may actually end up being like 10 or 47 microfarads, not quite 100. Come on. What are you doing? Okay. What am I missing? Is that it? Umbra. I love this song. Is this Umbra? Yeah. Oh, listen to this. So beautiful. So beautiful. So like I said, Battletech soundtrack by John Everest. Highly, highly, highly recommended. I can't wait for 3 more days for the for the full album to come out. Okay. What else am I missing? I've got isolation on the input with the transformers. Everything to the right of those transformers is the analog ground. Well, there's really only that and those. 10K, 10K. I can adjust that one resistor, and I'll have to adjust that capacitor as well to set the gain. Or alternatively, I could adjust these resistors if I wanted to. I got a DC block cap there. That may end up being like a 10 microfarad if I want to make sure that I'm passing enough low frequencies. Although into a line level load here, well, let's go figure out what that would be. Again, my favorite. Let's say the line level, the resistance is 600 ohms, and I do, that is 1 millifarad. That's 1 microfarad. Yeah, so the cutoff frequency there, oh, haha, look at that. That is way too high. So yeah, I do want to have 10 microfarads, 26 hertz. That's much better. So that needs to be a 10 microfarads, assuming that this load here is actually a 600 ohm load. If it's like a 1000 ohm or a, well, no, 1000 won't be much better. Okay, value 10 microfarads. Let's make that correct. What else? What are we missing? So that was Battletech. Let's go. Let's listen to, do I want Hong Kong? Where, no, these are all messed up. What the what? Where'd the rest of these albums go? That is all messed up. Okay. That's Returns, which is different. Dang it, where'd those albums go? Okay, well, let's go to some of my other favorite soundtracks. Bastion by Darren Korb. I'll make sure to include these in the show notes too.
Listen.
No, not gonna. There we go. Okay, so what are we missing? We've got our analog ground. I think that's it. Entire schematic. Yeah. Annotate. Go with those. What the what? That looks right. SOIC 8. So, this is the previous version of the board, and I want to keep the same outline, and I want to keep these in the same place because that board was designed to fit into this package right along here. There's the inputs, the kind of the cutout for the inputs, and then the two holes over here, which are, here, let me orient it the same way. It's, no, okay, it's backwards. Unfortunately, there's a mirror image going on here, but it's oriented like this, which doesn't help you. But stay up there. Dang it. My springs are getting old. But so the kind of the route out for the inputs is right here. And then the two mounting holes are right here. And then the power input here, and then the mixer input, or I might have those backwards, but the connections to the rest of the system are on that side of the board, right? So they're facing out this way. They are for, here, let's do that. You know, for these two connectors, which are just two 2-pin 0.1 inch, the standard, I don't know what they're called, Anyway, those two connectors or those two cables go into these two connectors right here, and I want to keep those in the same place, and I want to keep these holes in the same place, and I want to keep these connectors in the same place. So I'm trying to figure out how to load. I want to get rid of everything else and then reload the net list. This could be. I could probably. All right, let's see what this does. Read current list. Unconnected tracks. Delete them. Extra footprints. Delete them. Single pad nets. Yeah, exchange. Go ahead and exchange. Let's see what that does. Okay. I think that did a lot of what I wanted. Okay. There's a lot of stuff in here we still need to delete. Almost worth just starting over. No. My live stream dashboard seems to be spinning. Hopefully you all can... Frell, knock that crap off. Hopefully y'all are still able to see me. Oh, that's what that is. Okay. That. What is that? Oh, it's gone now. Okay. Flip that up to the top. Okay, so we got things all over the place. Alright, let's put those back into place. Those were right. Okay. So, 47. Or any of the other 47s. There's one. So those are our load resistors. The next thing that they need to go into are the trim pots. So we got to figure out how we're going to fit 4 trim pots in here. May want to go horizontal with those, because those trim pots are wider than the connectors. Where's the trim pot? What? Where's? Did I lose a? Exchange foot. Extra footprints. Oh, okay, that's fine. Where did I lose it? Trim pot? What am I doing wrong? Seriously, there should be a 4th trim pot there. Where is it? That one. RV3421. Where's RV2? Am I going crazy? Shouldn't there be another trim pot around here somewhere? Any of you guys watching, do you see it? There should be a 4th trim pot somewhere. They're there. I RV2 due to missing footprint. What do you mean missing? It's the same footprint. Footprint potentiometer was not found in any of the libraries in the footprint library table. What the what? So for starters, are you guys, can one of you who's watching mention something in chat, because my dashboard video has been like spinning the little circle of death for a long time now. I want to make sure that the stream is actually still working. Can someone please let me know in the chat? Okay, potentiometers. There it is, 3296. Burns 3296. Got a bunch of 3296s. That might be the one. W. Yeah, I think W is the one I want. Inline screw up. Yeah, that's the one. So, apparently, KaiCat decided to change the outlines on me in the last year. Who didn't see that coming? And I don't know why 3 of the 4 worked, but the 4th one didn't. I'm not sure why that is. Okay. Well, that should do that. Let's see what's going on. Save that. Generate a new netlist. Generate. Read a netlist. Exchange footprint change. So we're going to be getting new pots. Yoink. Okay. No other. These errors I can ignore because that just means that these outlines don't have the thing, which is fine. All right, there's my 4th pot. Yep, those are going to be spaced out. That will not fit on the board. Though I think I could probably extend the board just a little tiny bit, but it's also just as easy to do that. Actually, hold on. These are definitely not going to fit. So I think I did that differently on a previous version. So let's look at what that might be. A different way of squeezing all of these to fit. Here, let's do that. I could fix that. Okay. Okay. I think that's probably the most dense that I'm going to be able to get these. Actually, you know what? I am going to flip those under. So 1, 2, 3, 4. Okay, so those are crossed. So I'm gonna, the transformer doesn't really matter, so I'm gonna actually swap those on the schematic. Do I literally want to do that? Flip them on both sides, but that will... Yeah, I think I do. So that's better. But looking at this, now I've got, yeah, see, I want the ground A on this side. They're all in the wrong side. Okay, so I want to swap the outputs. Just because I want the signal level to be closer to where it's going. Okay, we can do that. I'm going to do that in all cases. Hey, knock it off. All right. Read the net list. No other errors except for those. And now all of my transformers are wired up conveniently. Put that on the bottom side so that it doesn't interfere with these transformers. All right, so let's move these. These are the mixer outputs. Those are all twisted up. See, those are all twisted up. Well, that's unfortunate. Okay.
Build that wall up to the sky. Gonna build that wall up to the sky. Someday your bird is gonna fly. Gonna build that wall until it's done.
Oh, shoot.
Gonna build that wall until it's done. But now you've got nowhere to run.
Oh, I'm going to move that on the outside. Okay.
So build that wall and build it strong, 'cause we'll be there before too long.
All right, so that's all the speaker side of the isolation transformers. Actually, you know what? Do all of these right here. All right. So I now want to lay a ground plane underneath my transformers, or a analog ground plane, as it were. So we're going to do bottom, we're going to do ground A, and we'll do that. All right, we'll come back and do more of that later, because most of this circuit, I think, is going to use the analog ground as its plane. Oh no, this is the bypass cap. That one I do want on the bottom. Wait, nope, that's the output cap. Oh, nope, it is like that. Hey, Will. Yes, you do hear Bastion. I was playing, I don't know if you've heard it before, BattleTech. I'll go ahead and replay this album since this is the album that I was claiming I played and is listed in the show notes here. This is the BattleTech original soundtrack. We've only got 6 tracks right now. The album comes out in 3 days. If you haven't heard this yet, it is amazing. Yeah, so like I said, only 6 tracks are out so far, but highly recommended. John Everest does great work. He did the other Shadowrun soundtracks as well, Hong Kong and Dragonfall. Just phenomenal work. Super, super impressed with his work. Excuse me. Alright, so all of that is kind of wide, so let's just grab the whole thing and rotate it. Really? Not gonna leave it where I was? Alright, fine. You know what? I want that going the other way. Okay. So I'm thinking about ground planes right now. I want this to be over the ground analog plane. We are in that weird state where we're going to have both grounds are in play here. No, I can't do those. Well, start with, so Will is saying that this program looks like fun, but he doesn't know how to design circuits. Start with a simple circuit that somebody else has designed and work on copying it into the schematic tool. You know, you don't actually have to be designing the electrical side of things to learn how to use the tool. And then as you're learning the tool, you can start learning some of the electronics and look at a circuit that somebody else designed and say, you know what? This is good, but I want to modify it in this one little tweak of a way and make that change as you're doing the layout. And that gets you familiar with the, the schematic tools, and then also starting to learn with some of the electronic stuff and getting into all of that. I would encourage you to play with it anyway, even if you don't think you know it. I think you know it better than, or you can know it better than you think, but anyway, you know what I'm saying. Let me do it this way. Oh. We'll do ground. So I'm going to define a real ground at this point. And the transition from analog ground to power ground is basically there. Oops, shoot. All right, I'm going to move that. Dang it. Okay, so Will's complaining that after years of learning this stuff, I just don't know how to determine what values I need on components. That is, that's legit. That is, where the engineering and electrical engineering comes in. It is not always... Whoa, I don't know what that was. Sometimes it feels like black magic voodoo. But there is actual logic behind it, and usually it's something like Ohm's law or Kirchhoff's current law or those kinds of things. We were just, I actually was just talking about it a little bit earlier in this podcast in the context of how the mixer section of, whoa, that's not what I wanted, how the mixer section in this circuit worked. And, I mean, it's all knowable. It helps to have a good Elmer or a good teacher, someone who can stand by you and work with you to figure out all the quote-unquote hard parts. And I put those in quotes because they're not hard. They're just non-obvious. Let's put it that way. It's not the kind of thing that you're going to figure out on your own just by kind of hacking around on it. Well, maybe you can. I'm not going to say that you can't because there are people who definitely do that. But, don't be discouraged if you need a little bit more help. That's totally legit. Okay, so I'm going to extend my analog ground to that. All right, with that extension, then I should be able to... Let's see here, some of these... It's an analog ground. Let's go via that to the bottom. Oh, damn it. Okay. Volts. Let's see here. That's a real ground. Okay. Yeah, we can deal with that. And 12 volts will come around over there. Yep, so that's all fine. So let's do the 12 volt ground. Whoa. Where are you coming? Oh, that's the bypass cap. Okay. Yep, I need that in there, but I'm going to flip that over. Put that on the bottom side. There we go. Okay. So... Why are all the grounds thick, but the 12 volt isn't? Because I lost that when I deleted a bunch of stuff, so I got to do the design rules again. So I got a power node, anywhere to power 5 volts. Yep, there is no 5 volts anymore, but there is a 12 volts. C10 pad 2. I don't think that's the one you think it is. I think you're thinking C1 pad 1. C1 pad 1. Power. Pull that over there. Okay. So now all my 12, my ground, all that is in the nice thick traces. Okay. So let's delete that trace, and redraw those. Yep, there we go. You are going to go ahead and get via'd to ground, like that. And then... put on the right layer. This should be on the other side. I don't think it much matters, but... Okay, so we still have power and ground, and then we have output. I'm going to use that cap to bridge. Will KiCad... Okay, hold on. With KiCad, you don't have to draw the components, right? It has a library of them already built into use. So it does have a large library, and there are a lot of things that you can use built in. However, it is not everything. And there are occasionally times where you will have to build out a component. Sometimes the components that it comes with are not the way you want them to be. And so you... brain. So you end up having to redraw them anyway, even though it may have already had a component. It's not the way you wanted that component, so you choose to redraw it. I've done that on many, many, many occasions. Oh, it's going to be unfortunate for power. Okay. Let me via that one out. Okay. Let's do another ground plane for power. We're going to do a top copper. We're going to do plus 12. So I got a plus 12. I got my bulk cap going there. Do I even actually want a power plane? I may not, because I only need that and that. Nothing else needs power. All right, I'm going to undo that plane. We're just going to draw our plus 12s. Okay, so let's get this connected in. I do, however, want to do that. And too close. Okay, fine. Okay. So I would specifically want the ground to hit the capacitor first and then go into the pad, even though it's a little bit of a wide. In theory, this should go through the capacitor, but it's close enough. This is not so critical that that's likely to be a problem. This one, on the other hand, I think I want to split off and be fed separately. So where do these go? All the way there. So I got these two paths that need to cross. And no, I kind of don't want to feed it through there. So let's go ahead and do that first. Why do you... What? Bottom copper. Okay. I don't know why there was one on bottom copper there. This is the business end of this whole circuit, so let's get that going where we want it. Now I got to figure out how to get power to the other side. No worries. Well, thanks for coming and join me. He says he wishes he could stay longer, but he's got some other stuff to do. This looks like fun. I'm going to check out KiCad. Thanks for streaming. You're very welcome. Yeah, let me know how it goes. I would love to hear stories of you screwing up your first boards and figuring out how to fix them and all of that fun stuff. That's the fun part of all of this, right? So tell me the stories. I want to hear about it. See, if I were smart, and actually, you know what? I can redo those. Hang on, those positions are not critical. Okay, that's what I'm gonna do. Undo that, undo that, undo that. Go ahead and delete that. Okay, we're gonna move these around. We're gonna move that one over there, that one there, but we are gonna swap these labels. All right. The orientation of those two is not critical from a use case where the board's going to be in my the box project where it goes here, so I can swap those around pretty easily. Now I just need to decide what I'm doing with the rest of this. So that capacitor bridges the two different ground systems. Do I want that one on the bottom? No, everything else is on top. Layout-wise, that's kind of ugly, but circuit path-wise, that's about optimal. Okay. Nope, don't need that. What I want is that to a via. Okay. Yeah, I'm going to put that there. Put it closer to where it's needed. Yeah, even better, because now I can split from that node. Yeah, that's what we want. I think I like that. What are those? What are those? Values. So 0.04, 0.04, and 0.006. Okay. So I'm going to create a new text there. I'm going to make it 100 microfarads. 0.04, 0.04, and 0.06. We're going to put that on the front silk. Normal, center, justification. Okay. We'll do 100 microfarads there. And we'll copy that and do 100 microfarads there. And reality is those will probably be closer to like 47, maybe even 10, because we don't need a whole lot. But we're going to make it good. All right, so artwork, always important. All right. Look at that. What? Why are you? Oh, because I'm pushing the wrong key. Okay. Aha, I do want to number those inputs. And I want to number, okay, yes. Yes, I do. So 4. And 4, the pot for 4 is over here, right? And 3 goes there. Is there not a number 3? Okay, I'll copy that. Copy that 3. That goes to this pot. And then 2 goes there, and that 2 goes to... Oh, that's unfortunate. That pot there, and then 1 goes there, and we'll copy that 1 and put it right there. Come on. Okay. What does the DRC say? Let's do a bug check. Do we got everything? Hello, Zoe. You just saying hello, or you need my attention? Okay. Actually, edit. Let's make those left justified, because why the heck are they right? Oops. Okay. Is that all of it? The DRC looks good. I'm pretty happy with that. Let's see what Osh Park says. Let's see how Osh Park renders this. Nope, not that one. That one. Speaker mixer. I'm going to have to go real soon here because we got some friends showing up this afternoon. But hopefully I'll be able to get this ordered before the end of the day. You're not complaining about any problems. Less than $20 for 3 of them. View image. Oops. How about we do new tab and view new tab. Okay. So that's what the bottom looks like. Oh, I should probably move those 47s over. Okay, speaker level mixer by Smitty Halibut SLM, blah, blah, blah. There's a VIA right in the text. Let's move those 47s. Oh. Okay. Got some text right on top of a VIA. Okay. So all that looks good. Let's look at the top. So those 1, 2, 3s, and 4s can move closer to, well, maybe not. Although the 3 looks a little off. Maybe it's not. Okay. Nope. What? Oh, you are, that's part of it. Edit to make you left justified. Okay. Yeah. Okay. What else? So we've moved those over closer to the connectors. 1 to that one, 2 to that one. I can't think of a better place to put that. Oh, I've got these RVs and the T's that need to move. I bet I have that render turned off. No? References. There they are. Dadgummit. Okay. What the what? What the? Okay, forget you. This is Kenneth's favorite part of me working on things. And by favorite, I mean the part where he loves to mock me. Yellow I can ignore. Value 1 microfarad. Oh, if that, no, that stays. U1, we can get rid of that. C4 we can get rid of. Reference C3. Oh, the yellows we can ignore because they won't render. Ba-da. P6 we can get rid of. Okay. I think that's it. So let's see what happens now. Cancel. Start over. Processing. Why did all my other stuff close? Okay. Is that larger? Oh, that is larger. Okay, we'll stick with this one then. Okay, so there's our bottom. Text looks better. 1 micro, that's close enough. 47s are all good. So this bottom side looks pretty good. Top side. 1s, 2s, 3s, and 4s look good. 1s and 3s, 2s and 4s. I think it's the best we're going to do. Whoa! That is not where I expected it to be. Okay. I will put those on the bottom again. But we've gotten rid of all of our errant... those are not consistent. I should probably move that up a notch. Okay, mix out, ground out, power. Yep. All right, so I'm going to move RV3 up a notch, and I'm going to fix the kerning on the 68. Okay. Edit. Oh. Okay, never mind. Thought there was a way to set it to be left or right justify, but apparently I can't set that on text properties. Okay, that's unfortunate. All right, well, we'll deal with that. And then the other one was RV3. I do want to drag that up by 1 notch. There we go. And then that's going to make that be weird, so I will take that track and move it out there. Keep thinking that these are on the front side. They're not. They're on the bottom. Yep, that's where I want that. Okay. What else? That's looking really good to me. One more round. Did I save that? Yep, I did. Okay. Any questions about what I've been doing or what the board is or any concerns? Do you see anything I was doing wrong? Any questions? Whatever. Hit me up in the chat because I think I am pretty darn close to clicking order on this thing. Oh yeah, I was going to fix that. Looks like I got some extra text down there. Yep, look at that C1. Go away. That's what I wanted to see. Got it. And then I was going to move these to a different layer. So what is my bottom? Yep, okay, so that's all on a single one there. Okay, so all I have to do is edit that, move it to bottom mask. Yep. Edit, bottom mask, edit, bottom mask, edit. Okay. So now it'll show up on the bottom side because I don't really have any top ground planes or copper pores. The only thing would be over here, but I think I'd rather just use a big thick trace for that. I'm also kind of tempted whether I want thicker traces between these and the load resistors. But I'm not going to bother with that right now. Okay. Famous last words. Hopefully this will be the last load and I'll be able to click order on this. YouTube tells me I've been streaming for 2 hours now, so that's usually kind of where I like to top it out. Not do any more than that. We'll see. Oops, not what I wanted. Ah, really? There we go. Okay. Hey, my fishies are back. My caps are facing different directions, but I think I'm all right with that. They're 90s. They're not 180 out. 90 out, I think, is all right. I think I'm ready to place an order. I'm going to do that, but I'm not going to do it on the stream because credit cards. So I think I'm done with this, and I'm hoping it's going to work. So we're doing the trim pots before we feed them into the audio isolation transformers, and that will hopefully make it saturate less and make it work better. So let me go back here. Thank you very much for watching. Smitty working on something. Been working on a speaker level mixer today. Go back to the beginning of the stream if you want a explanation of what it is that I'm building and why I'm building it. Otherwise, if you're interested, find me on Twitter at Smitty Halibut. Same username I have here, SmittyHalibut. That's where I do most of my like online social networky type stuff. You can also leave comments here on YouTube. I will read them when they're down below and hopefully respond if it's, you know, something that requires a response. Otherwise, if you're a ham radio operator, I've also been hanging out on DMR talk group 31075 lately. That's kind of the Baynet group, or the group centered around the Ham Radio Workbench podcast that I've been kind of friends with for quite a while now. So, yeah, reach out to me. Tell me what you guys are working on. I always like hearing your stories, hearing about what you're doing and problems that you ran into and how you fixed them and all that kind of stuff. So tell me all the stories. I want to hear them. Thank you very much for watching, and we'll catch you next time. I will, when I get these boards in from Osh Park, I will try to set up a camera on my workbench over there and maybe stream some of the assembly and testing of these things. Hopefully. We'll see how that goes. I'm also going to be at Hamvention in 4 weeks. I leave in 3 weeks because I'm driving out from California, and that's going to be a fun drive. Kind of a journey for me. So if you're at Hamvention, pull me aside, find me there. Again, KR6ZY, crazy with the 6 in the middle. And we'll talk to you later. Thank you so much for watching. I really appreciate it. And yeah, be good humans. And now I always wait because YouTube likes to shut it off. And there's my be good humans and stopping.